Hello everybody. I'd like to take this chance to explain to you a little bit about the Tethys platform and how we've used it in SERVIR in the past and possible ways that we might be able to use it with the coming applied science team projects. And it's not going to be for everybody, but we found it very useful for many of the scientists last time who have data visualization, dissemination needs, and don't really have expertise, experience with web app development, but want to be able to put their solutions in the web. I want to begin by explaining a little bit about our research laboratory and where we come from. We've been pioneered the development of computer graphics at BYU and have a long history of developing scientific visualization software, and in particular pre and post processing of numerical models for water resources applications. Our tools, developed primarily in collaboration with the U.S. Army Corps of Engineers and Federal Highways Administrations, have been used in thousands of organizations all over the world. More than 10 years ago, out of our effort in the Environmental Modeling Research Laboratory in Aquaveo, a private company located nearby BYU was formed to capitalize on the potential not achievable at the university environment and continues to support and develop these tools. In the past several years, we have moved away from desktop solutions to cloud-supported hydroinformatic visualization and decision support tools through the support of an NSF Cyber Infrastructure grant and now a NASA ROSAS proposal with both the SERVIR and GEO programs. And this has really helped us advance the Tethys tools, and then we've used that as part of our AST2 project. We saw that there was a lot of need, similar need in those projects, and so I'd like to open up the possibility for how that might be used in this round. As you know, NASA aspires to have an application readiness level achieved at the level 9, if at all possible. And it's not to say that, and this level 9 is to say that there's a sustained level of use by stakeholders. And Tethys platform really can help us achieve this higher level of ARL and be able to provide a more sustainable way that these applications can live on as we move out of the AST projects and try to turn them over not only to our hub partners, but more importantly to those stakeholders. I want to use some examples that are from our project, my area in particular in hydrology, to kind of illustrate how this works. And the reason that cloud computing is such a game changer, especially in developing countries, is that hardware and software systems that deliver the value-added information is developed in applied science projects like we have worked on here at SERVIR do not have to be replicated by every hydromet service or similar agency that's trying to uptake our applications, using the data and models derived from Earth observations for decision making. Instead, the value-added information can be used directly in their decision-making process. But in order to leverage this new paradigm, NASA and other big data providers need to be delivering services, not just the raw data components. And Tethys helps to do that, and then provides a mechanism to host and brand where they are at in ways that are easily scalable depending on their needs and capabilities. And so what we're really trying to do is move away in the world of hydrology, to move away from where we're providing the underlying DEM, land use, and MET files so that they have to create models on their own cyber infrastructure and then validate and curate them in order to make decisions. Instead, we can, at a global level where the data resides, work on that level, model, create our own models, validate, so that we can focus on the application through services of making those decisions. If we're going to do that, there's 4 barriers that we need to be able to overcome in order to do that. One of them is that cyber infrastructure and workflow. A second is being able to easily communicate these large volumes of data to the end users in ways that supports the decisions that they need to make. We need to help them understand how to use it, and that's where we can really focus our effort if we can more easily deliver them through web apps. And finally, we need to be able to provide ways for them to validate and have confidence and trust in the services that we provide. So this is kind of a schematic of the paradigm that we're trying to use. If we look over on the left, you can see we have big data, lots of files, scripts, and workflows and models that develop solutions that our stakeholders and advocacy groups need to use to make decisions. And so what we really need is this thin client interface in the middle, a simple web interface that helps bridge that gap from large data to information that's actionable for the decision makers. And that's where Tethys got developed as part of an NSF project in order to lower that barrier for scientists who don't have all of the skills in order to create these kinds of web apps in order to do it in an efficient and possible way. And so if you're going to develop a web application, you need to have skills in HTML and CSS, JavaScript. If you want to make a map, then OpenLayers and GeoServer. You need to know additional functionality about JavaScript and how to do geoprocessing. 52 North is a package that does that. PostGIS, you need a database that's spatially enabled. Python has become far and away the language of choice for scientists, and there's many libraries out there. And so many of us understand Python, but not all the rest of these tools. And then you need a web framework like Django that has security and user management. All of those skills and things need to be put together if you want to create a robust web application that's useful for an end user. And so what Tethys does, we like to think of that as putting all of these components into a big box of WebGIS stuff. And then it's enabled through Python as an underlying programming language, and that allows us to then create applications that with Python alone that are able to leverage all of that. And so in summary, it might be easier to understand Tethys as a collection of open source GIS web development projects that have been combined into a framework that allows both development and deployment and management of web applications through a portal. It allows developers to use common scientific language Python to harness a software stack that includes HTML, CSS, JavaScript, spatially enabled databases like Python, and map services such as OpenLayers and GeoServers, and the web framework Django that provides security and user management. By using Dockers and software services such as GitHub, a scientist can literally set up a portal and create a web app in less than an hour with some basic understanding of how the web works and some Python. Obviously, to create more advanced apps takes additional time, but it truly is and has lowered the barrier for scientists to package and deploy their data and models and achieve higher ARL levels than would otherwise be possible. Further, because it is open source with an ever-increasing number of applications, it's becoming easier to find existing apps with similar, if not identical, functionality that can be used and reused as a starting point to replicate functionality that can be tailored to specific decision support needs. And many of our applications are similar in that respect. As an example, an app was developed for NASA's Land Information System LIS model in one of the HKH projects during AST, being used for drought management and seasonal forecasting. When another colleague with a similar project in West Africa also built on LIS became aware of Tethys, he was also able to see that all of this work could be exposed and have greater impact using the same, if not slightly modified, apps, which has created the push by the West Africa Hub to get their own Tethys portal and leverage apps useful to them. So again, back to my example for our project, just to illustrate how this works. We work with ECMWF and develop, they provide a gridded rainfall runoff or surface runoff product, which we downscale and map to rivers and then route through a river network throughout the world so that we can provide services. First of all, the data services themselves, the forecast and simulated time history, and also with the help of our partners at Esri, a web mapping service for animation. These two services then are consumed by applications, and a variety of different apps, and I'll demonstrate a few of them here, can be created that use these two data services with Tethys. And you can think of your applications similarly creating these kinds of outputs and results that could then be easily deployed in a Tethys app. So if I look at Tethys is not just the app, but it's also a portal. So this shows our GeoGlow Stream Flow Services tool made within a Tethys app, but you'll notice in here it's also within a portal that has other applications, and I'll come back and talk a little bit more about that portal in a minute, but I'll play this animation that shows the Tethys app that delivers this global streamflow data product. And so I'm going to zoom in on South America. This different region, you can see how it displays a map. As we zoom in, we'll see the watershed polygons and then the river networks. And then we interact with this service to get the current forecast just by selecting on a stream. It then loads a time series and plots that. That data can also be downloaded and combined with other applications, as you'll see in a minute, to show a variety of different things. So this is a typical Tethys application, again hosted within a Tethys portal, where there might be many applications that are hosted, and each app, just like you would on your smart device, is designed and tailored to perform a specific function, and then can be reused and remapped. And during the AST2, there were more than 20 different apps that were developed not only at Brigham Young University, but in conjunction with other PIs by the Science Coordination Office in Huntsville, as well as our partnering hub at ECMOD, and some of the other hubs also got involved in the development of these applications. So you can see that, and many of these apps are created by starting from an existing app. We were able to share and collaborate that way. At the end, or at some point during AST2, each of the hubs stood up a portal. Many were hosted by the Socrates cyber infrastructure, but a follow-on project with NASA we've been working on is now creating an app warehouse, not just in GitHub, although all of these apps are stored in GitHub, but also the ability to pull into a new portal, be able to select and download existing applications and start from there. And it also makes it easier to create the portal and then add to it the applications that you want to be able to do, and then create new ones, modify existing ones in order to be able to stand up a composite solution. And one of the advantages of doing it this way is we go to a stakeholder with a variety of different apps from different AST projects, they can have a similar look and feel, or they don't have to learn how to run an application in multiple different ways. And so over the next year, we'll be completing this project, which will make it much easier to facilitate the deployment and sharing and collaboration of apps across the SERVIR network, but really across NASA and the other organizations that are supporting Tethys as well. So again, just a couple of different examples. This was the GeoGlows. These are all global applications that are available and work anywhere in the world that we've created. There's also has been customized in Central America. You can see an app that's branded for them, and then we've taken out the stream flow in that area so that they have their own Hydra viewer over Central America region. It accesses the same services, but in this way they're able to customize and really brand, if you will, an application for their specific area. Similarly, we've done this in Colombia with EDIAM, and so you'll see the application, another Tethys portal with different applications, some of them the same. You might start from the same base GeoGlows tools, but here we have an application that does the stream flow and then combines it with their own in situ observations to show these time series. And you'll see the observed discharge that's being pulled from their database and then compared against our model simulated discharge. And then different kinds of metrics and analysis can be performed using this application and using Python and the tools that are available in there to be able to do that. We've done a lot of work in the Dominican Republic, and so here's a portal that shows a very similar arrangement where we're pulling the stream flow forecast, but we're overlaying it with a separate model, the flash flood guidance model, so that it's a multi-model approach and application for them to be able to use and view their results and make decisions. There's other applications that I haven't demonstrated, that these global ones in GeoGlows that I mentioned, that are also very useful, and I bring them up in particular because many of the results that you might have would be reflective of this. See if I can make this animation play. There it goes. Here we're going to drop a point, at a given location, and then we're drilling down through a time series of netcdf files and pulling that up and plotting it. And so this kind of data results is very similar for many of the kinds of projects that I've seen in SERVIR, and it would be easy to take this application and adapt it for your own use. Another application aggregates time series of rasters over a set of polygons. So in this case it's rainfall, and we're just going to select a polygon from a different weather met forecasting system, and then it aggregates the total precipitation over that polygon and plots it, and again makes it available for download in a way. And so again, I see many different applications across SERVIR that might benefit from that kind of a workflow, and there's already apps that have been started and could be built from. Similarly, GLDAS, I mentioned the Land Information System from NASA that is used in a lot of different modeling like GLDAS. And so again, a time series of rasters in netcdf format with different variables that can be animated in a display and then drilled down through to get time series at a point or aggregated over a polygon. One final application I'll show, and this is actually one that is going to be developed by my colleague Norm Jones here at Brigham Young University working in West Africa, and it's a well management. So that here we have a sparse number of wells that have been interpolated to a raster, a time series of raster, and now we can see both the static well data as well as the dynamic interpolated rasters that come from that data that fill in the gaps in time and space. So a variety of different apps that have been developed. And in summary, Tethys is a unique solution. It's a data to services. It increases application readiness levels. It's collaborative, replicable, and scalable. There's an opportunity, I think, during AST to leverage for other SERVIR projects. I know that SERVIR has contracted with our partner, Aquaveo, to provide training at RCMRD and ECMOD and also at the Huntsville SERVIR Science Coordination Office during the coming year. And I like to offer a possibility of holding a boot camp training collaboration perhaps at BYU next summer, where you might send your student, come yourself, a postdoc. We might spend 2 or 3 days in training and then a couple of days maybe in consultation and collaboration, trying to figure out if there are already applications that would apply to your project and how to get started on that, if that's something that would be of interest and need in your particular project. A couple of questions that you might have that I'll try to answer in this presentation. You know, doesn't NASA already provide these things with the applications like Giovanni and Worldview? Is NASA alone in supporting Tethys, or you know, what's the larger support of Tethys? And also, how is it different from Google Earth Engine? Doesn't Esri provide such a solution commercially? What are some of the relationships that way? And as with respect to NASA Worldview and Giovanni, indeed they are already developing such tools. Tethys platform, though, fits very well into this ecosystem and provides an important link to customize solutions for end users and stakeholders, not only to access the raw data needed for problem solving, but also provide a means for applications to process and add value to this data through models and other workflows whose custom results are not served by these larger systems. And then, you know, besides NASA, there's other organizations, particularly the Army Corps of Engineers, is supporting Aquaveo in continuing to develop the Tethys interface. So it's continuing to improve and become more robust. And as I mentioned, SERVIR is contracted with Aquaveo in order to help develop some training and provide that, and it will be available. With respect to Google Earth Engine and Esri, Google Earth Engine is a wonderful resource for scientists to gain access to so much Earth observation data and create solutions that help us understand our world better. However, when creating models and workflows that result in derivative information services, those data cannot be pushed to Google Earth Engine for storage and replication very easily. So if you have your own custom model, it's not easy to integrate that. Tethys apps help bridge that gap. In fact, some Tethys apps access Google Earth Engine data in their workflows, but they are not restricted to that data or the functionality that is there. So you can combine the two, but it's really hard. If your solution is totally derived from use of Earth observation data that resides on Google Earth, that is probably a better environment than Tethys. But if you create your own models and create your own data, then but might want to access Google Earth Engine, then Tethys really is a solution that might help with that. Esri provides more capability to deliver custom services that provide value-added information from the raw data sources, but it requires a proprietary license for either the creation of those applications or usage or both. That's getting easier. We partner with Esri all the time. Tethys works, and it's compatible, and we work together with them to create solutions. So it can work well together, but Tethys provides an independent open source solution to be able to do that. I'll just go through really quickly now many of these applications just to give you an idea. Our streamflow prediction tool application, we've done a flood map that combines location of point facilities with flood mapping. We've developed static flood maps and time series and probabilistic flood maps from our data. We have a whole Python library of time series metrics for root mean square error kinds of validation, or Nash-Sutcliffe in the hydrologic world, and many others. We've created an interface with GRACE data to be able to display GRACE anomalies. I already mentioned the groundwater level mapper application, the GLDAS viewer I showed really quickly. There's an application in the Dominican Republic that combines the stream flow with flash flood guidance. Another one takes the forecasted stream flow, inflows into reservoirs, and then does reservoir operation management at the different locations in the Dominican Republic. Allows the operators to manage that. And I also showed the hydro viewer in Colombia that combines with their in situ data to do validation. An application in East Africa that was worked on in the last AST was a VIC interface for the RIAS model, and another one that was done in the Mekong was the Altex to do altimetry readings to get water information. An interface to pull out the chirps in the GEFS data, similar to what you'll find on ClimateServe, and a model, the Darwin model that was used in conjunction with VIC. The furlough model, this is the one that also accessed the Google Earth Engine data and was part of the West Africa project, and another one for viewing vegetation. A high watt interface, this is meteorological data similar to the GFS at a higher resolution that was done in the HKH region with one of our partnering AST PIs, and a land data simulation system for Bangladesh. An Nepal drought watch monitor using again a form of the land information system model, and then they combine that together to get statistics and create an agricultural drought watch application that was done by our collaborators at the HKH region. A Bangladesh transboundary flow application, and a hydro viewer that was customized for Nepal, and then other web mapping services added for that. This is the more generic list observation data, a SWOT model data in the Mekong for a model that was created with SWOT in one of the last AST projects, and it also provided access to this NASA data access to set up input files for the SWOT model. And finally, an EcoDash system modeling tool that I don't really know that much about was created by the Science Coordination Office. So those are many of the different applications that have been created with Tethys, and we look forward to more discussions about that. And if you're interested, please feel free to reach out to me, and we hope to be able to talk and share more about it. Thank you.